Alright, so this is Chapter 10, Section 1, Exploring Conic Sections. Our learning objective is to graph and identify conic sections. And our key concept is a conic section is a curve you get by intersecting a plane and a double cone. What I love about the word conic section is conic means cone and section means a part of the cone. And you can see these two cones are lying one on top of the other. By changing the incline of the plane, you can get a circle, a parabola, an ellipse, or a hyperbola. And down here, you can also use lines of symmetry to graph a conic section. And we've seen that a lot in parabolas. Alright, so we're going to graph each one of these. We're going to use symmetry to help us out. We're going to start our graphing exploration by making a table and plotting points. So in this case, we're going to graph a circle. And to do that, we're going to make a table, plot the points, and connect them with a smooth curve. This is our plan of attack. So what is the graph of x squared plus y squared equals 9? What are its lines of symmetry? What are the domain and range? So if I were to plug in -5 into this equation and figure out what y is. So I need to manipulate this equation a little bit. So I'm going to subtract my x squared. And take the square root of both sides. When I do, I have, you guys know, when we take the square root of both sides, you have a positive value and a negative value. So we're going to find, and this is just calculator chugs. So I'm going to plug in -5. So I'm going to go -5 squared. I'm going to go 9 minus 25, and then the square root is, there's no undefined. So at -5, because I have 9 minus 25, which is -16, you can't take the square root of a negative number, so it's there's no value at -5. So when I plug in -3, I'm going to square -3 to get 9. 9 minus 9 is 0. Square root of 0 is 0. Now plug in -1. -1 squared is 1. 9 minus 1 is 8. Plus or minus the square root of 8 is 2.8. And then 0. 0 squared is 0. 9 minus 0 is 9. Square root of 9 is 3. 2 squared is 4. 9 minus 4 is 5. Square root of 5 is 2.2. 4 squared is 16. 9 minus 16 is -7, and I can't take the square root of a negative number. Okay, so let's plot these. When x is equal to -3, we are at 0. When x is equal to negative 1, we're at positive 2.8 and negative 2.8. When x is equal to 0, I'm at positive 3 and negative 3. When x is equal to 2, I'm at positive 2.2 and negative 2.2. And then I'm going to plot the points and connect them with the smooth curve. Circle. Circle. Yay. Okay, so let's look at the domain and range of this. Our domain, we found out, it's our x values that are greater than or equal to negative 3 and less than or equal to 3. And then our range, if we look here, our range are these values. It's anything y greater than or equal to 3 and less than or equal to 3. Our lines of symmetry, let's think about that. I know the x-axis is a line of symmetry. We know that the y-axis is a line of symmetry. I say y-axis and then I can't write the right equation. Are there any other lines of symmetry that when I draw it and fold it in half along that line, the circle will line up perfectly? What about this line right here? The line y equals x. What about this line right here? Y equals negative x. What about this line right here? We have an infinite amount of lines of symmetry because a circle, as long as you're going along its diameter, you're going to have a line of symmetry. Alright, so let's graph an ellipse, and just so we know what we're aiming at here. It's like an oblong circle. And in fact, an ellipse, a circle is a special form of an ellipse, kind of like a square is a special form of a rectangle. So we're going to use the same operating procedure. We're going to make a table and plot the points and connect them with the smooth curve. So I thought we could use this equation here. 2x squared plus y squared equals 18. And plot some points and find the line of symmetry in the domain and range. So the first thing I want to do is I'm going to solve for y. So if I have 2x squared plus y squared equals 18, I'm going to subtract 2x squared from both sides. And I'm going to take the square root of both sides. And this is just calculator chug again. So I'm going to plug in -4 and square it and times that by 2. And I get 32. So 18 minus 32 is negative 14. I cannot take the square root of a negative number. So right here, I'm undefined. All right, let's plug in negative 3. So if I go negative 3 squared, that's 9, times 2 is 18. 18 minus 18 is 0. So that's plus or minus 0. Yay, a real number. Then we have 0, x. So x is 0, I get 0 squared is 0. 2 times 0 is 0. 18 minus 0 is 18. And the square root of 18 is 4.2. So this is plus or minus 4.2. 3 squared is 9. 9 times 2 is 18. 18 minus 18 is 0. And this is still 0. Interesting. So then 4 squared is 16. 16 times 2 is 32. 18 minus 32 is a negative number. So this is also undefined. All right, so let's plot these points and see if we can connect it with a smooth curve. So I have negative 3 and 0. I have 0 and plus 4.2 and minus 4.2. And I have 3 and 0. And then I'm going to connect them with a nice smooth curve. And it's going to look like an oval. Yay. Easy. All right, so we need to look at lines of symmetry. Thankfully, it's an oval. And we know we definitely are symmetric here on y equals 0. I didn't say it this time, so I could actually write this. And we have a nice line of symmetry right here at x equals 0. But if I went diagonal on these lines of symmetry, I would not get 2 halves of an egg that match up. That's the way eggs work. Sadly enough. My nice little oval. And then let's explore the domain and range. So my x values, I cannot go beyond 3 and negative 3. X is restricted. And then my range values, I cannot go. Right here I have, how I have it indicated is 4.2 and negative 4.2. And that's going to have to be an approximation until we learn more about ellipses and graphing them based on their equation, which we will. All right, graphing a hyperbola. I thought this was important, so I pulled it from the graph is a hyperbola that consists of 2 branches. Its center is the origin, and it has 2 lines of symmetry, the x-axis and the y-axis. So we're going to graph a hyperbola that's going to have 2 lines of symmetry, the x-axis and the y-axis. We're going to use the same process as we were using before. And the only thing different in this scenario is that I'm going to solve for x instead of y. On the table. So if you look at the equation here, I'm going to add y squared to both sides. I get x squared equals 16 plus y squared, square root. And x is equal to plus or minus the square root 16 plus y squared. Just because of the positives and negatives, this will make my life a little bit easier. So I'm going to pick a y value. and solve for my x values. And let's start with, let's go -4 and -2, 0. Let's go 1 and 3. Just added an extra one. I added a sneaker on there. So now on my calculator, I'm going to plug in a y value and get out an x value. So if I plug in -4 for a y and I square it, I get 16. And then I add it to 16 and get 32. Then I take the square root of 32. And I get 5.7. And that's plus or minus. Right, I do the same thing with -2. -2 squared is 4. 4 plus 16 is 20. And the square root of 20 is 4.47. So 4.5 plus or minus. 0. 0 squared is 0. 16 plus 0 is 16. Square root of 16 is 4. So at 0, we are plus or minus 4. If y is equal to 1, 1 squared is 1. 16 plus 1 is 17. 17 and a square root is 4.1. This is 4.1. And lastly, but not leastly, 3 squared is 9. 16 plus 9 is 25. Square root of 25 is 5. So it's plus or minus 5. All right, let's graph all this craziness. If I'm at -4 on the y-axis, my x values are -5.7 and +5.7. If I'm at -2 on the y-axis, I'm going to delete or erase these axis dots. I'm at -4.5 and +4.5. If I'm at 0, I'm at -4, +4. If I'm at 1, I'm at -4.1 and +4.1. If I'm at 3, I'm at -5 and +5. So we need to delete these. And let's make our smooth curves. Go. Smooth curves. Nice little mirrors. If you look, I have the x-axis is a line of symmetry and the y-axis is a line of symmetry. And in fact, to me, it kind of looks like a basketball. Here's how you'll see hyperbola problems. It'll ask, what are the center and intercepts of the conic section? And it's this one right here. What are the domain and range? Oh, we didn't do the domain and range. What are lines of symmetry? We did lines of symmetry. Domain and range are here. So, sorry, let's go back to this first problem and talk domain and range. So if you look at your domain, the x values that are not allowed are in this area here. So my x values are anything less than or equal to -4 and anything greater than or equal to 4. And then my range is all real numbers. because it's going to go positive y and negative y. All right, so looking at this number 4, what are the center? So this is easy. The center is the origin. The intercepts, so let's look, we have no x-intercepts. Let's spell intercepts right now. So the intercepts are actually only here on the y-axis. All right, so our intercepts are at 0, 1, and 0, -1. I have no other intercepts in that because we don't cross the x-axis at all. And the domain. If you look, there aren't any restrictions on the x values. I can go a bunch of positive x's and a bunch of negative x's. So my x value is all reals. It's my y value that's restricted. So my range, if we look here, we can't have y values in between 1 and -1. So I need my y's to be either less than or equal to less than or equal to -1, or greater than or equal to 1.